Good morning, everybody. Welcome to your first video lesson. We'll be doing section 2.1. Follow along as if you were in class, so get your notebooks out and open to your warm-up section, and go ahead and try this warm-up. I'll allow you to pause the video, and once you're done with the warm-up, you can resume the video to check your answers. Okay? Go ahead and pause the video. All right, you're back. So I think you're probably ready to check your work. They gave you the domain for your table, and the domain was 0 to 15. So you do want to set up that left-hand column to be all of the numbers between 0 and 15. Okay, now the equation that we're using, I can't see it anymore because I scrolled down too much, but it was y equals x squared. So you just take each number and square it. Hopefully you can do these in your head, but if the numbers get too large, then go ahead and use your calculator. 0 squared is 0. 1 squared is 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared is 36. 7 squared, 49. 8 squared is 84. 9 squared is 81. 64, I think I said 84. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared, 169. 14 squared, 196. And 15 squared, 225. So just a little fun mental math activity to get you going and get you prepared for what you'll be seeing in the lesson today. So go ahead and get your notes out and go to section 2.1. I do have some definitions for you to write down while you watch this video. You can pause it if you need to get to the right section and then resume the video when you're ready. All right, we are doing section 2.1, finding square roots and comparing real numbers. First off the bat, a square root is basically a number such that if b squared equals a, then b is a square root of a. You can go ahead and write that down. I think most of you have used square roots, but then we'll do a couple examples. All right, so for example, let's try the square root of 49. So you're asking yourself what number squared equals 49? And that answer would be 7. Because 7 squared is 49, 7 is a square root of 49. Now, what if they had a problem like this? Negative square root of 36. Well, you would start by square rooting the 36, which is 6, because 6 squared is 36. And then you'd apply that negative sign, so your overall answer would be negative 6. And then in a lot of these problems today, you'll be seeing that symbol. That just means positive or negative. So if the problem looks like this, positive or negative square root of 4, then you would square root the 4 and get 2, and then apply the positive negative symbol in front. So it actually means there's 2 solutions, positive 2 and negative 2. All right. If I ever go too fast, feel free to click pause or rewind the video a little bit, but we're going to go to the next slide now. All right, perfect squares are numbers that if you would square root that number, you would get a nice integer solution. So you didn't know it, but in the warm-up, you actually made a list of perfect squares. So 1, for example. 1 would square root very nicely and have an answer of 1. 4. 4 would square root very nicely and have a solution of 2, because the square root of 4 is 2, and that's an integer. So just completing our list, 9 would be next, because it's 3 squared, so square root of 9 is 3. 16, 25, 36, 49, 64, 81, 100, 121, that's 11 squared. The square root of 121 is 11. 12 squared is 144. 169 would have a square root of 13. 196 would have a square root of 14. and 225 would have a square root of 15. So it would be a great idea not to necessarily memorize everything on this list, but be familiar with them enough that if you recognize them and you're taking the square root, you know it's going to be a nice answer and you can find it quickly. Those are your perfect squares. Okay. Go ahead. Let's try these ones. Actually, try these three all by yourself. Go ahead and pause the video. When you're ready to check your answers, click play on the video, and then you can see what I've written down. Go ahead and pause the video and give it a try. All right, are you back to check your answers? The first one will be -3, the second one would be 5, and the third one would be positive or -8. All right, same deal on the next slide. I want you to try these all by yourself. So go ahead and click pause and try them, and then click play when you're ready to check your work. You're back. So, did you get positive or -9, positive or -5, and -20? If so, great job. Give yourself a pat on the back. All right, I think it's a great time for me to give you the key word phrase of the lesson. I'm going to ask you about this in the little quiz at the end, but the key word is Monday, because today's Monday. Pretty funny, huh? So the key word today is Monday. All right, let's try this next one. We got a word problem. I do suggest drawing pictures when you're doing word problems involving area. The top of a folding table is a square whose area is 945 square inches. And I would write that like so. Approximate the side length of the tabletop. So basically they had a side length here and a side length here, and they multiplied side times side, in other words, side squared, and they got 945. So to kind of work backwards, we can square root the 945 to find the length of one side of the table. Now it did say approximate to the nearest inch, so when I typed it in my calculator, you can go ahead and try that, you get 30.7. We would want to round that up to 31, and our label would be inches, because that's a length, not an area. All right, hopefully that went well. Going on. Now it says approximate the square root to the nearest integer. There, they want you to try this mentally. That's what they want you to do. Now I realize you have a calculator on your desk and you'll probably be tempted, but try not to use it. Let's just talk through how we would do this. 32 is between the perfect squares 5 and 36. So we know the square root of 32 will be somewhere between 5 and 6, because here, let me write that out. So 32 is bigger than the square root of 25, which is a perfect square that I've got memorized, but less than the square root of 36. So I know the square root of 25 is 5, and I know the square root of 36 is 6, so my answer has to be somewhere between 5 and 6. So since 32 is closer to 36 than it is to 25, we would probably say the answer is closer to 6 than it is to 5. Hopefully that makes sense. If you do type it in the calculator, it's 5.65, but yeah, it is closer to 6 because 32 is closer to 36 than it is to 25. All right, the square root of 103, that's really, really close to the square root of 100, so I would just approximate that into 10. And then the 48 is really close to the perfect square 49, and the square root of 49 equals 7. So we probably approximate this to be pretty close to 7, and then I apply that negative sign. -7. Go ahead and pause the video and try these three all by yourself. Resume the video when you're ready to check. All right, the first one, 29 is closer to 25 than it is to 36. So the square root would be basically close to the square root of 25. And then I applied my negative sign that was out front. 108 is close to 100, and if I would square root 100, I'd get 10. So that's 10. And 53 is a number pretty close to 49. The square root of 49 is 7. And then you apply the negative sign that was out front. Okay. Let's talk about different types of numbers. This is kind of like some vocabulary words. You definitely would want to think about writing these down. I'll give you a second to get your notebook ready. Whole numbers are the numbers you would traditionally see on a number line that a teacher would have at the front of her board. You know what those number lines look like. They have 0 in the middle, and they count up 1, 2, 3, -1, -2. Oh, rewind that idea. I am sorry. It's early in the morning, and I kind of messed up. But whole numbers actually start with 0 and count up 1, 2, 3, 4. I am so sorry about that. Don't know what I was thinking. This O right here is what reminds me to start with 0 and count up using counting numbers. I was jumping the gun. Integers are actually numbers you'd see on a number line. So integers are all my whole numbers, but then all their negative counterparts. -1, -2, -3. And this would continue in both directions. So the integers would go on forever, both in negative and positive directions. Rational numbers are any numbers that can be written in fraction form. Any numbers that can be written A over B. So I'll just give you a few examples of rational numbers. 2/5. That would definitely be a rational number. 10. 10 would be a rational number because I could write it as 10 over 1. 2.1 would be a rational number. I could write it as 2 and 1/10. Or 21 over 10. Therefore, if you would have a decimal that either stops or repeats, it would be able to write as a fraction, and it would be rational. So a decimal that would repeat is 1.3 repeating. That could be written as 4 over 3. Now, where you get into irrationals are things that cannot be written as fractions. And those are decimals that are really, really messy. They go on forever. They have no pattern to them. So a good example of that would be the square root of any non-perfect square. Go ahead in your calculator and try to square root 3. It's 1.732050808 dot, 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 dot. You're not seeing it, but that decimal is going forever. There's no repeat to it. It cannot be written as fraction, so it's irrational. So most of the irrational numbers are going to be your square roots of your non-perfect squares. And then real numbers are any number that exists. Any number that exists. So you're probably wondering, what in the world, doesn't every number exist? Well, some things that I could write out in mathematics actually would not exist. Here's an example. 7 divided by 0. Go ahead and try to type 7 divided by 0. My calculator gives me an error because that cannot be done. So that would be something that is not real. So I'm going to explain what real numbers are by giving you examples of things that are not real. And then another not real number would be the square root of -16. Go ahead and try to type that in. Your calculator is probably telling you error, non-real answer. All right, I have this cool little chart. You don't need to write anything down right now, but I want you to look at it. Basically, it says real numbers are all numbers that are rational, integers, whole numbers, or irrational numbers. So it's like an umbrella term for all of the others. And I'm just going to uncover some examples. So irrational numbers, they give you square root of 2. Oops, I uncovered everything accidentally. Square root of -14. Pi. Pi is definitely irrational. It goes on forever. That's the most famous irrational number. Can't believe I didn't think of that. And then rationals, you've got your fractions. and your decimals that can be expressed as fractions. Whole numbers are all those counting numbers starting with 0, and then integers include the whole numbers' negative counterparts. These are just some examples. So basically, here's how this Venn diagram works. All whole numbers would be integers, and all integers would be rational. But then no rational numbers would be irrational, and no irrational numbers would be rational, because there's no overlap. Alrighty, moving on. Now we're going to identify these numbers, stating what type of numbers they are, and then put them in order from least to greatest. So first of all, I'm probably going to get these all into decimals so we can compare them easier. The square root of the negative square root of 16 is -4. And then we have 3.2. And then -3 over 2 is -1.5. And the square root of 9 equals 3. Let's go ahead and stick them in order first, and then we'll state what kind of number they are. So the -4 is actually going to be the smallest. It would be the furthest left on the number line. Then -1.5. Then 3. Then 3.2. All right. State what type of number it is. So -4 would be a real number because it exists. It would be a rational number because I could write it as a fraction, -4 over 1. And it's an integer. So you can have more than one labels for a single number. -1.5 is real because it exists. It is rational because I can write it as a fraction. In fact, it was written as a fraction originally. It is not an integer. It is not a whole number. So I think we're done identifying that one. All right, 3 is real. It does exist. It is rational because it can be written as 3 over 1. It's a whole number because I can use it to count. It is not irrational. Oh, it's an integer. Almost forgot. All right, I think that covers it for 3. And then 3.2, definitely real, definitely rational. I could write it as 3 2/10. It is not a whole number. It is not an integer. So I think that's good. All right, I want you to click pause on the video and try these all by yourself. You're putting them in order, least to greatest, and then identifying what each number is. So pause the video, try it by yourself, and then resume when you're done. All right, you're back. The square root of 5 is approximately 2.236. That's going to be an irrational number, but I went ahead and just jotted it down. Then we have -6. Then we have 2.5. Then we have -24 over 5. I typed it in and got -4.8. All right. So going ahead and putting them in order from least to greatest, we've got -6 first, then -4.8, then 2.236, and then 2.5. Now, something I forgot to do on the last slide, and I kind of apologize for this, is just rewrite what they look like originally. So originally, this one looked like a -6. Originally, the 4.8 looked like -24 over 5. The next one originally looked like the square root of 5, and the 2.5 was a 2.5. That's probably what they actually want you to do, was to write it in original form. I am sorry about that last slide. I should go back, but it's okay. And now let's identify each number what they are. -6 is a real number. It's an integer. It is not a whole number. It would be rational because I could write it as -6 over 1. -24 over 5 would be real. It would be rational. It would be not an integer, not a whole number, so I think we're good. Oh, this is our first ever irrational number. It's a decimal that goes on forever. And then 2.5 is real, rational, because it could be written 2 5/10. That's a fraction. It's not a whole number. It's not an integer. So I think we're good. All right. Evaluate the following. 11 minus the square root of x when x is 81. So we're going to plug that 81 in for x like this and go ahead and solve it. So the square root of 81 is 9. So I'm basically going to take 11 minus 9 and get 2. All right, can you try the next one all by yourself? All right, if you're ready to check, go ahead. If you're not ready to check, click pause. The square root of 121, that's a perfect square, and it equals 11. My order of operations says to multiply next and get negative 33, and then I have to subtract that 7. So negative 40. All right, we got a couple word problems. I think we have 2, and then we'll be done. So a local park is in the shape of a square and covers an area of 3,600 square feet. So I draw up my picture so I can see it in my head. We are talking about the length of one side of the park. Very, very similar to what we did earlier. So basically s times s, or s squared, equals 3,600 right now. And we just simply take the square root of the 3,600 and we'll have the length of one side of that park. So it's 60 feet. It's the length, so we'll write it in feet. Alrighty, last one. The U.S. Department of Transportation determines the sizes of traffic control signs that you see along the roadways. The square Pennsylvania State Road sign has an area of 1296. That's supposed to be a square. I don't know why I drew a rectangle. There, it's a square. 1296 square inches. Find the side length of the sign. So side times side, or side squared, is 1296. And you want to go ahead and square root both sides. 1296 was a perfect square because I got the solution of 36, which isn't a whole number. It's an integer as well. 36 inches. All right. Well, thanks for following along the video. After you finish the video, there's going to be a quick quiz just to kind of ask you a few questions. Make sure you watch the video. But hope you had a great day, and I will see you later. Here is your homework for when you're done with the little quiz. I'll talk to you guys later.